Started, guys. We'll have folks keep joining us, but let's utilize the time and let's go through. Hello, everyone. It's great to have you here. Good morning to my fellow folks in the Pacific, and good afternoon to my fellow folks in the Eastern Coast. I would like to especially thanks to the guys who are joining us from different geographies outside the US, especially for India and a bit of European countries. It's almost a bedtime. So thanks a lot, guys. You guys are great. So why we are doing this? Why we are here? So we are going to talk about powering through Snowflake in our Cut to Clutter series. We are basically picking technologies who are making a difference. And while picking these technologies, we wanted to cover a lot of things that goes around development, not development per se, but the things that surrounds development, and try to be really focused on few things. So there is a famous say, right? Once the outlier book came into the market, it becomes a norm to understand in our head that if you want to be really great at something like top of your field, you need to invest something like 10,000 hours. But that's a good amount of time. If you just convert it into working days, it's almost 5 years. Now think of that. Further analysis on these things are, if you invest focus 20 hours of your time to learn anything, you will be at a stage where it's just enough to self-correct yourself. And that's our focus over here. Be really focused on while listening the webinar, and post it also, sharing our knowledge with community. With that, I would like to talk about briefly why we are here and who and what we do. So we are here to cover Snowflake, and as we see the trends in data management, all the services needs to be available in one place. It has to be scalable, it has to be multi-cloud, minimal administration and ops, data quality and governance should be embraced in it, data recovery, and at the end, it should be easy for the business users to consume. For who this webinar is, it's for the developers who use Snowflake day in, day out, but would like them to focus on all the surrounding things that goes along with the development. It's for the managers and executive who focuses on the funding side of it and eventually responsible to deliver the product or solution on Snowflake. We want them to think around different things in their planning phase, not just the development part of it. What we are covering? We are covering Snowflake as a complete package, how it is marching towards it, the costing side of it, how it is usage-based cost, the data recovery side of it, and then some of the accelerators that we have built in-house to covering certain gaps that exist as of now. So with that, I'll greatly take a pleasure to introduce our speakers. Marcus today is here with us. Hey, Marcus. Marcus has 20 years of work experience in data management field, has seen all from legacy to the cloud side, and really interested in deep diving into these cloud technologies, understanding them at a core level, and then try to bring his insights around, apart from development, how these cloud technologies has different things wired up. Ninad, hey Ninad. Ninad is going to be the co-speaker over here. Ninad has been the instrumental person in our team to work on a lot of accelerators, which we are building by identifying what all things which are not yet covered can be solved with our accelerators over there. Ninad carries deep interest in Snowflake, and he'll be talking about a few things along the line with Marcus. So with that context, I would like to move towards our first topic of the day and pass it to Ninad.
Hey, Sushil. Thank you for the introduction, and so good to see you everyone here. So just to start with a small story, not so long ago, setting up a data warehousing for all the organizations meant purchasing an expensive and specially designed data centers. Now, even though organizations bought these specially designed data centers, over the years, companies built thousands of ETL pipelines. Now, even though they built these thousands of ETL pipelines, data wasn't trustworthy. Data wasn't trustworthy. There were high security risks, and there was also high maintenance. Now we had these problems. So, we had to find some solution. So voila, we found the cloud. Just moving ahead and starting with our first topic, evolution of ETL from legacy to cloud. Now, for a moment, it looked all good. We were moving and migrating from our legacy system to our cloud-based system. So it looked good. There were no problems. But here comes the funny part. Every solution that is solving one problem is also creation of a new problem. Now, with the cloud-based technologies and with the hassle-free and real-time cloud-based infrastructure, there were multiple problems. Like, we had multiple platforms where we need to manage those multiple platforms. We need to sustain those platforms. Along with that, the ongoing cost was increasing. So we had this problem. So just deep diving into the components of the ETL which are causing issues, or what are the components used into the ETL cloud and legacy. Moving ahead to next slide. So these are the source systems like Kafka queues, MariaDB, and Oracle. These all consist of transactional data. They collect all the transactional data. Post that, we need to move this data and schedule our frameworks in the cloud, in the legacy system, using job scheduler like UC4 and Airflow. ETL system is basically used to transform our data from source to data warehousing, and the data warehousing target databases are like Snowflake and Teradata. It includes cloud as well as the legacy system. So these are the simple and day-to-day ETL components which are used in multiple organizations. Now just moving ahead with a simple cloud-based architecture which is used across multiple organizations. So the very first thing, ETL component, is the scheduler tools. Scheduler tools are like heart of the system, where they schedule our ETL as well as the ingestion part. Now ingestion part, that is the ingestion framework, takes all the data from source components, flatten or version, and then send it to ETL tools. Now the ETL tools like Informatica, Matillion, Hevo, EatLeap, these tools transform data as per the business logic, as per our requirement, and then they store into Snowflake. Now, if you see here, we are using multiple platforms. So multiple platforms, as in we are using schedulers, we are using ETL tools, we are using ingestion framework, which includes AWS. So if you see here only, we have like 4 different platforms, and the ongoing cost for this platform is increasing. Now, moving to a better solution for our cloud-based architecture to our next slide. Here is Snowflake architecture one-stop solution. We can say Snowflake is like Brad Pitt or Tom Cruise of our cloud architecture. And I'm sure most of them will agree for this, because you find everything under one roof. So starting with our ingestion process, where we can connect our Kafka streams directly to Snowflake, and we can run real-time Snow pipes. So there is no ingestion framework, as well as there is no scheduling process. Post that, if you want to perform our ETL strategies or ETL versioning, we can use streams and tasks which can help us perform change data capture and SCD versioning as well. Now, someone might have some requirements of scheduling their jobs. So how will Snowflake help it? Now, Snowflake has a feature in task where they can schedule their ETL jobs as well. So with this, I would say that everything which is required for a day-to-day ETL jobs and day-to-day ETL architecture is available in Snowflake. And that's why I mentioned that it's a Brad Pitt and Tom Cruise of cloud architecture. So I would next ask Marcus to take lead of the next slides. Thank you.
Hey, thanks, Nanad. Okay, so in this next section, we're going to talk about use-based costing. And go to the next slide. So Nanad's been talking to us about Snowflake, and Snowflake's done a great job extending their platform. They're adding a lot of development tools, pipeline data processing tools. And this innovation has driven a lot of adoption. So all of you are here for Snowflake, and many others are using Snowflake. At Factspan, what we're finding is that this adoption of Snowflake is also leading to an increased need to understand costs and understand usage, and to be able to sort of monitor and control those costs. Okay, so in the next few slides, I'm going to talk to you about a few things that can help you make sense of that use and the cost, and just sort of allocate your resources efficiently.
Yeah. Hey everyone. Just a little housekeeping. Just keep asking questions on the chat, and we'll take those questions towards the end. Thank you.
Okay, so before we get into it, though, first thing I want to do is review how Snowflake does accrue costs. You may know some of this already, but it's good to know if you don't. So Snowflake's cost model includes 2 items, really, and that's the cost of storage and the cost of compute resources. So the cost of storage is calculated according to the number of terabytes of compressed data. So Snowflake does compress your data when you load it or when you store it in their database. And so the amount of compressed data per month per terabyte. And the cost is dependent on what region the storage is located in. And then the charge for compute is based on the compute resources that you use or that are consumed to process your queries or run other background services. So on your screen, you can see a chart that shows Snowflake's warehouse sizes. They do offer warehouse sizes in t-shirt sizes ranging from extra small up to 4 extra large. One thing you'll notice is the credit consumption per hour doubles each time you go up by one warehouse. So going up from an extra small to a small or going to a medium, the credit cost per hour doubles. And it's also important to know that essentially the total processing power of a warehouse also doubles. So the number of nodes or the number of cores available to run queries and do processing is twice as much for each incremental increase in warehouse. Now, you might think that any warehouse you could use for any load, but that's not true. So every warehouse size is not really it's not the best choice for every workload. Now on this slide and on the screen, I want to make 3 points. I'm going to talk to you about the warehouse optimization, but also a couple of points about resource monitor and auto suspension. On this chart, what you're seeing is across the x-axis, it shows each warehouse size from extra small up to 3 extra large. Now this chart shows the amount of runtime required for a query on each warehouse and also the cost associated with it. So on the far left, on the top left, you can see the dark blue line representing runtime for this test query. It ran in 13 minutes on an extra small, and the cost was 88 cents. Now, if we step up to a small warehouse, and you'll recall that a small has twice the processing power, and lo and behold, the runtime gets cut in half. So it's almost exactly cut in half from 13 minutes down to 6.5 minutes. Cost stays the same because the runtime is cut in half, but the rate of credit accrual is doubled. So it's cost twice as much to use a small, but the overall cost stays the same. Now you can see the trend continues up to a large, and then when we get outside the large up to the extra larges, you can see where the marginal improvement in runtime really wasn't that great, but the cost goes up a lot. So the main takeaway here is that your warehouse size does matter for your load. It's a little bit trial and error, but it's something to focus on your organization that you are using the right warehouse for whatever queries and whatever work you're doing. 2 other points about this on this slide real quick. Be sure that you're using resource monitors for your warehouses. A resource monitor is essentially going to limit the number of credits that a warehouse can accrue in, let's say, 1 month. It'll send you a notification, and it'll also terminate the warehouse if it exceeds that. And then auto suspension is a feature for a warehouse, which basically allows Snowflake to suspend the warehouse, including credit accrual, if there's no load on the warehouse. Okay, so on this next slide, we're going to talk about 2 functions that will give you some programmatic access to profile your costs. So since you know how costs are accrued, how do we monitor? Well, programmatically for developers and administrators, at least, there's a couple of functions you can use. On your screen, load history and metering history are both shown. The top shows the load, the average load for warehouses for periods of time. In this case, it's 5-minute increments. And then the bottom example is an example of the metering history function. It shows you the actual credits accrued for a warehouse for a time period. And then on the next slide, we also have something similar for storage. You can profile and monitor your storage costs programmatically. There are 2 functions in a view that Snowflake provides for you to allow this. We have one example here of a database storage. It shows each database the number of bytes used on the day that's applicable. And then the bottom example shows you a table view that will show you the size of tables. You can monitor that, including time travel and fail-safe. Okay, and one last point I want to make is that there is a UI that will allow you to explore, not programmatically, but you can explore your storage and your compute usage through a web interface that Snowflake provides. Okay, so in the next section, I want to talk to you a little bit about data recovery. Now, since we're talking about storage costs, I want you to know a little bit how backup and recovery features in Snowflake work. There's a couple of new things that they have, but also the cost implications that go along with it. Okay, so we have reasons for doing data backups, and backing up data is a good practice. It's a common practice for all users, developers, administrators, users. Whether you're talking about preventing or recovering from a mishap in your production environment, Maybe you make copies of data as part of a build process, or maybe we're just like copying data in a development environment for testing and reset testing. It is a common practice that we all employ. And then most data platforms also have some formal mechanism for backup and recovery, but it can be expensive and time consuming, and it often requires engaging a DBA. Now, Snowflake offers 4 things that I want to talk to you about and show you if you haven't seen it. The first one here is cloning. It's pretty much what it sounds like. We're making a copy of something, but it's kind of a nice feature. The next 2, time travel and failsafe, these are part of a continuous data protection lifecycle model that Snowflake introduces. And so they offer basically some ways to protect your data on an ongoing basis, your live data historically. And then there is a database replication feature I'm going to show you too. Okay, so what is cloning? Okay, so cloning, we just basically copy a table. And so the reason I want to show it to you, first of all, is that it's a great feature for backing up. You can back up a table. It's very low cost. When we clone a table, by the way, you can clone a database, schema, or a table, but I am using the table as an example, but you can clone the entire database as well. But anyway, when we clone a table, basically it's a mostly metadata operation. Snowflake creates a new object, a new table, and it has the exact same storage as the original table. This is advantageous because I can make a copy and I'm not actually reading any of the stored data, and I'm not writing any of the stored data. I'm not copying it. So I don't have the extra storage cost for the copy table, at least not yet. And I still have all the benefits of a backup. It's also a very efficient operation. It's a pretty low cost metadata operation, and you can use a smaller size warehouse to perform the operation. Okay, so on the next slide, I'm going to show you some cost implications though. So when we make a clone, what you need to know first is that all the storage is shared between the 2 tables, but that can deviate. As you do updates to the first table, inserts, deletes, that kind of thing, Snowflake will add new partitions, and those new partitions now only apply to the original table. But likewise, let's say the backup table stays the same. There are some old partitions that used to be applied to the original. Snowflake prunes those. And so now the total storage for the 2 table is increasing, and your storage cost is increasing with it. So cloning is a good way to do backups, and it's pretty low cost, and it has a low impact on storage, but it can deviate, and you can end up in a circumstance where you're paying the same for storage. Okay, so next let's talk about time travel. Time travel is part of this continuous data protection lifecycle that Snowflake offers. This is a feature where they essentially keep track of the history of the tracked objects so that you can go back and refer to that history for the entire time of the retention period. So let me show you what I mean. On your screen, you can see this time travel retention. It's configurable. It's up to 90 days. It can be 0. It's 1 day by default. Time travel can apply to an entire database or a schema. Again, I'm going to use a table as an example. So let's assume you have like a 30-day time travel retention period on a table. What that means is that at any point in time, as long as that retention period and the time travel is still ongoing, you can select from that table historically. So there's some examples on your screen here where I'm selecting from my table using the @ keyword and then putting in an actual timestamp, or using the before keyword as well. So in this case, time travel is actually keeping the whole history. Let's say, again, we had 30 days time travel retention period configured for a table. If we inadvertently drop that table, you can get it back using an undrop keyword that Snowflake provides. Just undrop the table. And you can do that for 30 days, which is our defined retention period in this case. Now, on the next slide, I'll show you what happens after 30 days. So after 30 days is over, on the 31st day, you can no longer select from that table. It has fallen out of the time travel retention period. At this point, it falls into another part of the lifecycle called failsafe. And essentially, Snowflake adds an extra 7 days of failsafe. Now, there are some differences. One is that you can't do operations on this data, so you can't select from it or anything like that. It is there, but the only way to get to it is to open a support ticket with Snowflake. And so really, like, using failsafe is not like you don't want to rely on it, but it is there, and it's something that you should know about. And it does affect your storage cost as well. Okay, so the last thing that I want to talk about with sort of storage or data recovery and backups is a data replication feature. This isn't like a new idea in enterprise warehousing, but Snowflake has got a pretty neat implementation. And I did want to point out that it is here and that you know about it. You can replicate an entire database or an entire account In the example on the screen, I've shown a replication of an entire account. I wanted to point that out because if you replicate from one account to another, they need to be within the same organization. And then also database replication, what you need to know a few things about it. First of all, it is a snapshot, it's a point in time snapshot. It is not a continuous sync of the failover. And then the failover can be updated to catch up during a manual sync process. You just refresh it, but it is a manual process. It's not like continuous real time or anything like that. And then you can schedule a refresh with the Snowflake tags to make that a little bit simpler. Okay, so next up, I'm going to kick it back to Nanad, and he's going to tell you a little bit about some things that we're doing here at Factspan with this amazing technology, Snowflake.
Thank you, Marcus. Thank you for the very good presentation. So starting with one of the interesting topic like accelerators. So why do we have accelerators, or why do we build these products? So the main thing, what I told at the very beginning, was with the solution, there are again some problems created by that solution. So we had this very good solution, which is a Brad Pitt and Tom Cruise Snowflake. But even though Snowflake has some problems where we are trying to solve it. So moving ahead with our very first accelerator is rapid failure notification. So the name itself suggests us what it is. It's simple. We provide failure notifications rapidly. Now the thing is, why did we decide to build this framework? The very first thing is currently there is no application or there is no feature in Snowflake available which will allow you to send automatically failure notifications when there are failures in snow pipes or snow tasks. If that happens, it can disrupt our daily SLAs and daily reports as well. So in order to understand the failures automatically, in order to get all these reports, we thought of building this rapid failure notification. So moving ahead with a simple architecture of rapid failure notification, on top of the architecture, you could see that is a day-to-day ETL architecture, which can be used into Snowflake. So we use AWS SQS, which triggers the snow pipe for the real-time copying data. Post that, we can process our ETL structure using tasks, stored procedures, and streams. So this is a day-to-day ETL architecture which is used in multiple organizations. Now let's say if there are any failures in snow pipes or tasks on stored procedures, these are stored into copy history and task history table. Now, not every team will have access to these tables, and it will be very laborious to go and look into these tables and find the failures. Every time we'll have to query these tables for every 5 minutes. So we found a solution. We built a Factspan engine where you can just plug this Factspan engine to your Snowflake environment, and you'll start getting notification on real time as soon as there are failures. Now, just to elaborate a bit on Factspan engine, we just use external functions and API integration from your business account, a Snowflake's business account, to connect with our Factspan framework, which works in AWS. Now, Factspan framework pulls all the data from these tables, cleanses the data, and then it generates the incident as soon as there are failures. So along with the generation of incidents, we'll send a notification to Slack to the development team and the business team, along with the incident numbers as well. Post that, we generate an end of the day reports, which can be plugged to Tableau as well as Power BI, which will be sent to IT team using Outlook. Now, moving ahead to the benefits of the rapid failure notification, there's no dependency on the DBA team. The admin team who's going to handle Snowflake, we won't have to connect with them for every 5 minutes. We can understand all the failures as soon as there are failures. It can be leveraged by all the organization. You just need to plug our engine to your Snowflake, and that's it. You'll start getting all your notifications and failure job reports. It also provides you consolidated reports of job failures, which can be used by stakeholders to do some RCA and to improve their performances. And along with this, there is no additional cost included. We will be using the same Snowflake instance which you have, and there is no scheduling tool as well. So these are all benefits of rapid failure notification. Now moving ahead to a second accelerator, FACTOFLAKE. So I know it sounds cool and it operates cool too. Moving ahead to why did we thought of building this? The very main thing in Snowflake or in any organization is cost that they're spending on their database or in their cloud database. Now, the very main thing in Snowflake we could understand or we could see that is it's very difficult to get all the deeper insights of the credit consumption. Along with this, most of the applications, most of the organizations are using larger virtual warehouses, even though it is not needed. And this is leading to the heavy credit consumption. Now we thought, why not provide a solution where organizations can understand what are the pain points and what are the pain areas where they are spending lots of credits, and credits will be turning into dollars. Now we built a framework which will give you a deeper insight into your Snowflake resources. Along with this, FACTOFLAKE is using advanced ML techniques to predict your virtual warehouses as well. Along with that, it is also predicting your credit consumption for next quarter and next year. So moving ahead with the simple architecture of our FACTOFLAKE, it is very easy. Again, you just need to plug our Factspan engine with your Snowflake. And along with that, we'll just use one Snowflake tasks and Snowflake stored procedures to gather all the details from warehouse load history, warehouse metering history, query history table. Post that, we'll create fact table into Snowflake itself. Once the fact table is populated, our Factspan engine will get all the data and all the records from the fact table. Post that, Factspan framework will cleanse the data, apply advanced ML techniques, and it will generate a report on Tableau. This Tableau report will be sent to business team using Outlook to understand what are the painful areas. So moving ahead to deep dive into what or how our Tableau report looks like. So this is one of the report which helps you first understand what is the credit consumption with the comparison of Snowpipe, storage, and warehouse compute. Post that, you can understand the credit consumption by user as well. This will help you understand which user is running long running queries and which queries can be tuned. So if you see Douglas is using 80 credits, it means there is some problem, and we can go into RCA, which can improve your performance of the queries as well. Along with this, in bottom, we can see we can get query volume by R. Also, we can get what is the query execution time, and then we get the partner tools credit consumption. So partner tools is nothing but whether we have run it on Snowflake UI or any other ETL tools like AWS Matillion, Glue, and all those. So moving ahead to the second dashboard, this gives a deep dive analysis of how many credits have been burnt, what is the dollar amount, and the main thing, it will give you the future credits which are going to be burnt in your next quarter or next year, which is again adjustable. Post that, you can understand or you can pre-plan what is your Snowflake's credit consumption plan, and it will help you what areas are the pain point in your organization or your business unit. Along with this, we also understand which warehouse is actively running maximum queries and which is the active warehouse. So these are the two of the dashboards. There are multiple other dashboards, but we just wanted to show you just of what these dashboards look like, and we can include multiple deeper insights as per the expectations. So moving ahead to the benefits of the FACTOFLAKE, there are lots of benefits. We have just added 5 benefits, which we think are the most useful one. You get an end-to-end Snowflake cost management solution. It also helps you in upfronting the Snowflake budget planning. Along with that, you get the deeper insights of resource consumption. You understand what are the performance bottlenecks, and you can fill the gaps between the query tuning and the performance tuning. Along with it, we help you in understanding the warehouse sizes as well, which warehouse size is the exact and perfect for your ETL jobs, which will save you lots of credits. And at the end, this FACTOFLAKE can be used to save a lot of money for your organization. So these are few of the benefits, and I'll lay ahead to Sushil to take next part of the presentation. Thank you.
Thanks, Manal. Thanks, Marcus. And guys, as I said up in the beginning, right, this entire approach of us deep diving into a Snowflake is getting a little bit away from development, because that's where all of our heads generally go when we start in any project. But at a parallel, also look into the things which are as important as development when we are thinking of delivering a project. As a content to it, this is going to be a long series, and we are going to have a lot of sessions around it. The way question answer works is another way of learning things. So there are a lot of questions which are on chat and Q&A. I would like to have our audiences keep their focus on, so that while they're listening to answers of these questions, while we're talking through these questions and answers, there is a lot of learnings coming out of that, apart from what we have on the slides. So with that, I'll first start picking up certain questions and start directing it towards Ninad and Marcus. So very first one comes from Manjunath, who basically asks, he's a new to Snowflake, I'm learning it. Is this session for learners also? So yes, so I'll say, Manju, it's basically take something away from it, and try to have that perspective as you are starting on the development journey. Next question has come from another member. He's saying, does Snowflake only work with cloud tools. So Marcus, over to you. Does it only work with cloud tools?
No, I wouldn't say it only works with cloud tools. Snowflake is a cloud. So there's no such thing as on-prem Snowflake or anything. Snowflake is in the cloud, but you can certainly have like local things running using, for instance, the local command line or uploading data from a local on-prem server and things like that. So you can interact with it from other tools that are not themselves necessarily cloud tools.
Yeah, and I just want to add one more thing. It's cloud agnostic as well. So you can host it on AWS, you can host it on GCP, you can host it on Azure, all the three major ones that are there in the market. So that's one pretty feature about the Snowflake. You're not bind to one particular cloud technology for it. There's another question. In comparison to other tools, how cost effective is a Snowflake for typical OLAP processes?
Let me take this. So, in 2019, there was a benchmark test which was done by a very renowned blog called GigaOM. They compared BigQuery with Snowflake. Sorry, they compared Snowflake with BigQuery, Amazon Redshift, and Azure data warehouses. They ran total 103 tests, which included 30 terabytes of data in day-to-day life. So, Snowflake ran in 5,793 seconds, while as multiple other databases like Google BigQuery took 37,000 seconds. So here itself, it explained that Snowflake is way better than these of the databases. And this is just one test, which I'm telling, but along with this, there were 103 tests which were performed by this very renowned blog. And that's why Snowflake, we think Snowflake performs better as compared to all these tests.
Yeah, and I would add to that too, that one advantage with Snowflake, and as far as cost performance, is that you can scale into it as you wish. You don't have to buy a license up front. So depending on what you mean by cost effective.
The next question is more, or I'll say it's around development within a Snowflake itself. Is there any advantage of using transient table instead of permanent tables?
Yes, so transient table does not include failsafe, so it's actually going to cost less than storage, and you can consider using a transient table if you just don't have the same data retention needs, like build tables and things like that.
Okay, I hope that answers that. Another one, is there additional subscription or licensing costs involved to have a rapid failure notification framework implemented in an organization where there are no BI tools licensing or incident management process available at present? So now,
so we can modify our rapid failure notification in such a way where we can create our own incidents and drop it. We can notify those companies as well. So if you already have those tools, it's good. We can directly plug. If you don't have, we have a modified version as well, where you just need to plug, but you will surely get your notifications via mail or Slack, and we can create an incident by ourselves as well.
In comparison to, I think this is very similar to the previous one. Yeah, again, comparing costing of a Snowflake and OLAP process. So we'll pass on this one. What are the security standards followed by Snowflake to encrypt and safeguard customers' data?
Yeah, Snowflake uses encryption at rest always, and then they always compress all data that comes in. So everything that they store is encrypted. It meets several of the PCI standard, HIPAA, all the typical security standards for data like that are in Snowflake.
Yep, and adding to it, when we're loading or ingesting data into Snowflake, Snowflake uses this very strong AES 256 encryption, which when you're loading all those files into external stages and internal stages, so it's like the maximum level of encryption.
Okay. There's a scenario questions now. So database A is a clone of database B, suppose. What if the table in database B got deleted? Okay. Will I able to run my query on the table present in database A? If yes, then will I be charged for the storage for table present in clone databases. So Marcus, just to remove A and B for you, is basically what happens if you clone something from the primary database and table gets deleted in the primary database. Will you still be able to query the clone one?
Yeah, that's right. So if we cloned it, they become essentially different objects. If you delete one or the other, they're not directly tied together. So the answer to both of those is yes, you can use it, and yes, you will be charged for the storage.
Okay, that's interesting.
And then right below it, there was a question about cloning and replication. So what's the difference between cloning and replication? That's a good question. Cloning is really just a copy. Well, replication, when you replicate a database, Snowflake keeps track of that as a replicated object. And so at least one main difference is that you can refresh the target.
Cool. Makes sense. Yeah, it is interesting to know that even if primary doesn't have it, you can still query it on the clone.
That's right.
What are the feature sets used for FACTOFLAKE? So this one is for you, Nina. Model to predict the size of ETL warehouse. I think this is around ML piece of it.
Yeah, so there are multiple features where we are using, those come from warehouse metering history, query history. So some of them are like rows consumed into the history. Some it's like average queued overload time consumed to run a query, and the length of our query as well. So these are just 4 of the main features. There are multiple other features as well, 10 to 15 features which we are using to predict. But we take all the historical data and then we build a training data set and then predict it.
Okay, cool. Relevant one. What machine learning techniques or models have been used in FACTOFLAKE?
We are currently using time series forecasting. It's completely a time series forecasting model. We are planning to go into a classification modeling as well, which will give us a better accuracy, and it would be easy to predict as well. But yeah, currently it's time series forecasting.
Sure. Just as an overall question, who are the competitors for Snowflake in the market, and how ahead is Snowflake placed at present?
So I think I answered the first question that was about those 103 tests. So those are the competitors like BigQuery, Redshift, and Azure SQL Data Warehouse. And it has already been ahead with 103 tests. So I can say like it's 50 times ahead of all these warehouses, because the charges which are available, what Snowflake is charging clients is way less than all other databases, and the features as compared to them are way better, like cloning, time travel, and all.
Yeah,
and
built-in
Nina,
development.
if you can throw some more light on the first section, right, which was more around, it's not just database. So when we think it is in comparison with competitors,
exactly. It's not just a database. It's like a ETL tool as well as an analytical tool. We can perform our analytics, we can perform analysis, we can perform ETL, which we explained that it's everything under one roof. So if I want to perform, if I get everything under one roof, we would prefer go there. Why should we use multiple platforms? So, all these sustainment things and monitoring things is very laborious. So yeah, that's the reason Snowflake is way ahead of everyone.
This one is again around FACTOFLAKE. What are the feature sets identified for FACTOFLAKE model? I think pretty similar to other questions.
Rows consumed, time taken, average queued overload, average consumption time, bytes scanned, bytes written, just addition. Yeah, those are them.
Yep. First question towards the demerit side. Maybe Marcus and Anand, you both can take a shot at it. What are the disadvantages of Snowflake? So we talk about a lot of advantages, but what are the disadvantages?
So let me start. Maybe it would be great. Like we told, there is no failure notification as of now, and that's where we came with the solution. So we converted the disadvantage into advantage as well. So, currently they don't have integration with ServiceNow and notification and all those things. So that's one disadvantage which I could see.
Yeah, I'd say also just it's a different environment. It's really easy for cost to get out of control, for instance, whereas you can't really take it on-prem. If you can take it on-prem, like, a MySQL database, then your cost is limited to whatever your investment is. But Snowflake's a little more, it's a little bit weird. You don't really know what's going to happen until you're in it. to some degree.
Sure, makes sense. There's another one around cloud. So do Snowflake has its own storage, or its storage only depends on other cloud platform like AWS, Azure, etc.?
Yeah. So it basically uses the storage for the environment that it's running in, whether it's in AWS or Azure. And actually, now I think about it, you can set stages across environments as well. So Snowflake, I wouldn't say it has its own storage, but it's sort of using the storage of whichever cloud environment it's running in, plus wherever you point, you can point storage and stages to other cloud environments as well.
Sure, makes sense. General question, most of the orgs are moving towards a Snowflake. Yes, we see that. How feasible it is for business users to query on a Snowflake? How quickly a person can learn the tool, and what are all other reporting tools compatible with a Snowflake?
Yes, so I would say it's pretty easy to learn Snowflake, because if you're moving from legacy system to Snowflake cloud-based system, the integration of stages, integration of the cloud-based system is very easy. Snowflake also offers some basic courses where we can have batches, where we can earn some batches, and writing queries. Obviously, it's similar to all other databases. So there is no new languages for SQL. That's also easy to learn. I would say those are the advantages, and one person can quickly learn those things as well. And whatever new features like time travel and fail-safe, all those are available in SQL language. So as everyone knows, SQL is very easy to learn. That's why most of the business can easily pick it up.
Cool. Related to failure notification, next question, is there already an integration with Slack?
Okay, so there is no integration with Slack as of now, but there is an error integration with SNS for AWS. So what Snowflake can do, they have an error integration where we can link that with AWS SNS, and then AWS SNS can link to multiple other systems, whatever we want. It can be mail, Slack, yeah, but not direct from Snowflake to Slack.
Okay. Does Snowflake also provide OLTP services?
Well, it's not recommended, I think, is the official line. Did you have something else?
The follow-up question, if no, what are the OLTP service which best work with Snowflake?
So we can have anything. It depends upon the business requirement. We can have Oracle, we can have MariaDB, we can have Kafka queues. I would say Kafka queues would be the best because we can directly connect Kafka queues with our Snowflake. So all the queues or JSONs which are coming through API can be passed through our Kafkas, and they can be connected. So yeah, these are the ones.
I think on the chat window, there's a last question, and then I can look into Q&A part of it. Does FACTOFLAKE framework integration and workflow include additional costs apart from, say, FACTOFLAKE implementation? Are there going to be additional costs?
No. So I would say it's 0.1% of additional cost. We just need to run stored procedures once a day. There will be only 2 stored procedures which will be running. So it's like 0.1% for an organization. We won't have to add multiple other things.
Cool. There's one more that just came up. What about data recovery and backup in Snowflake? How secure in data in Snowflake compared to Azure AWS? I think we talk about backup and recovery in detail in the slide, but the second part of it, which is how secure is data in Snowflake compared to Azure AWS?
So I think it's same thing. The security concerns which we mentioned, Snowflake is using that AES 256 strong encryption. So that's why we think it's more safer. And rather than encryption, there are multiple advantages over Azure, as we mentioned about ETL and loading it very easily. While Microsoft environment is a bit difficult while linking it with other transactional or analytical databases.
Cool. Very interesting one. And Marcus and Anand, if anyone can take a shot at it. Why am I getting charged for storage in Snowflake? As you said, Snowflake is using the storage of different cloud provider like GCP and AWS.
Yeah, okay, so you do get charged for storage through Snowflake, but I guess it depends on what you meant by does Snowflake has its own storage. Snowflake is running in a cloud environment. So you can use storage, within Snowflake. It's still using something else underneath. When you create a stage, for instance, you have to point the stage somewhere. And so you pay that charge through Snowflake instead of through AWS.
Cool. Next question I'll say is more towards the consumption side. Can Snowflake directly connect to Pythons? Are there any ready-made connectors in place?
Mhm.
Yep, there are multiple
Yes.
connectors. The very basic would be Snowflake connector that is used to connect with Snowflake, and you can run multiple queries. And now there are multiple companies which are coming to picture, like Streamlit. The Streamlit can connect to Snowflake, run. It's again a library where you can perform analysis and analytics in that Streamlit library. So that is again acquired by Snowflake. So yes, we can connect, and it's very easy to use.
Yeah, and they also support Golang and I think JavaScript.
Cool. I'll take the last one, guys. I think rest of the questions looks very similar to what have been already answered. And this one towards the ML side, so FACTOFLAKE is based on the time series model as of now. Could DB parameters be predicted as a function of time?
Yes, they can be. As of now, we are using it. And that's why, as I said, we are expecting to increase our accuracy and move ahead with the classification models. So currently, yes, time series can be used. The thing is, why we are using is just a bit detail that these ETL parameters or the historical parameters are not going to be consistent for a week or a month or 6 months, and that's why we thought as of now we can use time series forecasting.
Sure. There's a suggestion, come question, and I can answer that. So by any chance, will you take a session on connecting Snowflake with AWS services like Glue? Yes. Our Cut the Clutter series will keep going on, and we are going to cover a lot of development sections in our next sessions. There's another interesting one. Name is not there, from anonymous user. Why should I use a Snowflake data warehouse service instead of AWS Redshift, assuming I'm already heavily invested in AWS as a customer? Why should I move out of wherever I am currently?
So one thing in Snowflake compared to Redshift is that Snowflake does give a little bit more separation between compute and storage, where Redshift, you kind of have to stand up a whole warehouse. It's also, if your warehouse size in Redshift isn't really large enough for what you're doing, it's a bit more headache to switch to another one, I think, if I understand it correctly. I'm not exactly a Redshift expert, but whereas in Snowflake, if you just want a larger warehouse for processing, you just use it at the command line, it changes instantly.
Cool. With that, folks, we are concluding on our question answer session, and would like to take a minute to talk about what next from here. Okay. So as we all are in knowledge industry, right, we are going to continue our Cut the Clutter series, and we pick a Snowflake as it is one of the emerging technology in a very important space, which is data management. And that's where you're going to see a lot of more sessions. We encourage folks to hang us, with us and keep attending our sessions. You'll keep getting the invites. Similar to this one, it's going to be a free webinar for everyone. We believe in community development, so there is going to be continual sharing of practical knowledge. And by the end of this webinar also, you're going to get the recording of the webinar, so you can go through it, leverage some pointers from here in your day-to-day work if you're already using a Snowflake. Increase the community size. So we see a good amount of participation today. We would like to have this community size growing with our newsletters, with a lot of things that you will see in mailers. So that's going to be the next over here as well. And a lot of ideation with this community. What we totally believe in is that there are projects which are too important for organization to start from top management, but there are always a lot of ideas that float around with each of the development guy or person who is contribute towards the organization. So we would like to participate in a lot of ideations with you guys. We'd like to come in a meeting with you, discuss about what's there, that are your pain points, do a lot of research on it and put ideas in front of you, prove it via POCs, and deliver on the POCs to make it a worth session to talk about with leadership that yes, this works and this should be converted into a project to basically get real fruits out of it. At the end of the session, folks, you're going to get a small survey, just have 4 questions in it with multiple choice answers and some text that you may need to write. We would like to understand from how the session went, what are your current pain areas, so that we can pick those ideas into our next sessions. We do have a team which continuously focus on Snowflake and innovations within it. So getting your pain areas and covering it into the next sessions will be of great use for the community. So please do participate in the survey that will come outside once the session gets over. With that, I would like to thank everyone. Thank Marcus, thank Hinal to come and present to us. Thanks the folks who make this possible, taking out time from your busy meetings and daily work. Thanks everyone for being late and joining us from geographies where it's already night. Thanks folks in the US. Thanks folks otherwise. You all have a great one. See you again in the next session.
Thank you all. Good day. Good night.
Thanks, everybody.